In this video, we're going to take a look at another application of being able to utilize iterated integrals and MATLAB. We're going to take a look at surface area this time. And you probably recall that to be able to find the surface area of a 3D function, you take the derivative with respect to x, you square it. You take the derivative with respect to y, square it, and then you add 1. And then you just take the square root of that and evaluate it over the given region. And obviously, sometimes this can be quite frustrating, or it could even be impossible to evaluate. But with MATLAB, it can make it a little bit easier. So let's take a look at an example. And we just have this parabola that's going to expand. And we're just going to go ahead and find the surface area over this rectangular region. So I'm going to define 4 symbolic variables, an x, a y. But notice that we have to square fx and square fy, so we have to do some algebra there. So I'm going to define an fx and an fy. Our function f is 4 minus x squared. And fx is going to be the derivative. And remember, we said that to find the derivative in MATLAB with respect to x, we go diff f comma x, and fy is going to be diff f comma y. What I'm going to do is I'm going to set up the integrand rather than just trying to program it all at once into an integral. So I'm going to call this variable the integrand. That's going to be equal to the square root of fx squared plus fy squared plus 1. Right? And that's just giving us what's inside of the integral. Now I'm going to go ahead and integrate with respect to x and then with respect to y. So I'm going to call this first. This is our first iteration of the integral of integrand. We're going to do that with respect to x from 0 to 3. And then second, we're just like we did before. We're going to integrate first with respect to y from 0 to 4. Now, let's go ahead, and you might remember in the previous video that we were able to get an exact answer and then also an approximate answer. So let's print f, and let's get first and see what happens with this. So let's say the surface area is, and let's just try the approximate first, because we know that that one's pretty much always going to work. So %.6f /n, and we're going to call the variable second because second stores the answer for this. All right, so let's go ahead and execute this. Oh, and I forgot the f at the end of fprintf. All right, so here's our surface area. Now let's see if we can get an exact surface area. All right, so I'm going to copy and paste this, and I'm just going to change this to %s. All right, get rid of the 0.6f, and let's see if we can get the exact surface area. We may or may not, not sure. All right, and it does give us the precise surface area for this. So we can say the approximate and the exact. Right, so that way, if we want them, either of them, then we can go ahead. All right, so pretty cool now that we can go through and do these applications of iterated integrals. All right, so we have one more section to work through, and that's going to be on Jacobians utilizing MATLAB.